In April 2019, humanity saw a black hole for the very first time, a ring of fire around a pit of perfect darkness 55 million light-years away. But the photograph that went around the world hid something stranger than the shadow at its center, because that same black hole is doing something that, written down, reads like a mistake. It is throwing a beam of matter back out into space. Thousands of light years of it, moving so fast it appears to outrun its own light. Nothing climbs back out of a black hole, and yet something is pouring off this one with enough fury to decide the fate of an entire galaxy. So here is the question NASA's telescopes have spent 6 years circling. If a black hole is the one place in the universe nothing escapes, what exactly is escaping this one? To feel why that question is so unsettling, you have to be honest about what a black hole actually is. Not a hole, not a cosmic vacuum cleaner. It's a place where so much mass has collapsed into so small a space that gravity wins completely. And beyond a certain boundary, the event horizon, the escape speed climbs past the speed of light. That's the whole definition. NASA puts it plainly. Within a certain distance of a black hole, nothing can escape. Not a spacecraft, not a signal, not even light itself. Cross that line and the universe has no exit for you. It is the most absolute one-way door physics has ever found. Which is exactly why the next part shouldn't fit. Because when we finally pointed our best instruments at these objects, we didn't just see things falling in. We saw things blasting out, jets, winds, beams of matter and energy screaming away from the edge of the abyss, crossing distances that dwarf the galaxies they live in. The escape happens just outside that one-way door, and the engine driving it may be the black hole itself. We're going to climb that escape, rung by rung, from the first photograph to a detection from 2025 that broke the models, and end on the one thing that could truly come out of a black hole, that we have never, ever caught in the act. Start with the photograph itself. On the 10th of April 2019, the Event Horizon Telescope released the first direct image of a black hole, M87 star, the supermassive giant at the heart of the galaxy Messier 87. The numbers alone are hard to hold in your head. 6.5 billion times the mass of our sun, packed behind that dark circle 55 million light-years away. To make the picture, astronomers turned the entire Earth into a single telescope. A network of radio dishes from Hawaii to the South Pole, locked together, all staring at the same speck of sky. But M87 star is not sitting quietly behind its ring. It is firing. Running out of that bright core is a relativistic jet, a narrow beam of high-energy particles that NASA describes as traveling at nearly the speed of light. It was not a surprise to find it. Astronomers had glimpsed this jet for a century, since 1918, long before anyone knew what a black hole was. What was new in 2019 was finally seeing the engine and the exhaust in the same frame. 19 observatories on the ground and in space watched M87 alongside the Event Horizon Telescope. The jet is real. It has been imaged again and again, and it is unmistakably moving outward, away from the one object that is supposed to let nothing leave. Hold on to the honesty here, because it matters. Nothing in that beam climbed up out of the event horizon. The jet is launched from the chaos around the black hole, the superheated disk of matter spiraling in, and the magnetic fields threaded through it. The horizon stays sealed, but right at its lip, just outside the point of no return, something is being hurled back into the cosmos with a violence we are only beginning to understand. So the real question becomes, how hard is it actually being thrown? The answer is harder than almost anything in nature. That jet from M87 star is not a wisp. Measured in the optical, it runs about 5,000 light years. Trace it in X-rays, as Chandra has, and its structure reaches out to something like 18,000 light years, a single coherent beam, longer than the distance from us to vast stretches of our own galaxy, fired from a region smaller than our solar system. A spark, the size of a city, throwing a spear the length of a galaxy. And it is fast. The particles in that beam move at more than 99% the speed of light, which leads to one of the strangest readings in all of astronomy. Because the jet points almost straight at us and moves almost as fast as the light it gives off, individual knots inside it appear to travel faster than light is allowed to. Chandra clocked 1 knot at 6.3 times light speed. Hubble measured others between 4 and 6 times. On the readout, M87 looks like it is breaking the one law that is never supposed to break. Except it isn't. And the truth is somehow stranger than the lie. Nothing is outrunning light. What you're seeing is a trick of geometry. A jet aimed nearly down our line of sight, chasing its own light toward us, so that each new flash arrives almost on the heels of the last. Stack those arrivals together and the motion looks superluminal, even though the knot is traveling just under the speed of light the entire time. It's an illusion. But sit with what has to be true for the illusion to exist. A structure thousands of light years long, made of matter, moving so close to the universal speed limit that it can fake breaking it. That is the speed at which something is leaving the neighborhood of this black hole. What could possibly throw matter that hard? For decades, the obvious answer was the disk, all that in falling gas heated and flung. But the leading explanation now is far more disturbing, because it doesn't only tap the gas, it taps the black hole itself. In 1977, two physicists, Roger Blandford and Roman Znayak, worked out that a spinning black hole is a battery. A rotating black hole drags space-time around with it, and magnetic field lines threaded through that whirling region get wound up like a spring and bleed the black hole's rotational energy outward along the poles as a jet. The black hole spins down a fraction and the universe gets a beam of fire. It is, in the most literal sense, the black hole being slowly drained. For 44 years, that was beautiful mathematics with no photograph to stand on. Then, in 2021, the Event Horizon Telescope looked at M87 star again, this time measuring the polarization of the light, the fingerprint of magnetic fields. And there it was, light spiraling around the ring in an ordered pattern, revealing strong, organized magnetic fields wound into exactly the kind of helix the theory needed to launch a jet. One of the astronomers, Sarah Isaun, put it simply, the field is spiral-shaped, which means it's able to launch a jet. Scientists called it the first real evidence that the engine is the spin. Not proof. The disk still plays its part, and the case isn't closed. But for the first time, we had photographed a black hole apparently powering its own escape. Now widen out, because a jet is only the narrow story. Black holes also drive winds, broad outflows launched off the disk, and these don't just punch a thin hole through space, they reach across an entire galaxy. The textbook monster is a quasar called PDS 456, more than 2 billion light-years away. In 2015, NASA's New Star and the European XMM Newton clocked its wind blowing outward at up to 1/3 of the speed of light, and carrying every single second more energy than 1 trillion suns radiate. Let that land. One black hole's exhaust second by second, outshining 1 trillion stars in raw power. And a wind like that does something almost worse than destruction. It sterilizes. As the lead scientist, Emanuele Nardini, explained, these winds drive the gas out of the galaxy. And that gas is the raw fuel for new stars. Push enough of it out into intergalactic space, and the galaxy simply stops being able to make stars. Astronomers call it feedback, or quenching. The galaxy isn't blown apart, it's starved. The black hole at the center, a single point of collapse, reaches out across 100,000 light years and quietly decides that this galaxy's age of star birth is over. The thing escaping the black hole ends up holding the whole galaxy's future in its hand. Which brings us to the detection that prompted this whole video, and to the moment the models started to crack. In May 2025, an X-ray observatory called XRISM, a joint mission of Japan, NASA and Europe, turned its newest instrument back on PDS 456. Earlier telescopes saw that wind as a smooth, steady outflow. XRISM saw the truth underneath. It isn't smooth at all. It resolved at least 5 separate streams of gas moving at different speeds, a clumpy, bullet-like barrage, firing outward at up to 1/5 of the speed of light. The estimate for how much matter is being thrown out between 60 and 300 suns worth of gas every year, and it carries over 1,000 times the energy of an ordinary galaxy's winds. And here's the unsettling part the scientists themselves admit. This clumpy, bursting structure challenges the existing models. They're not sure how it's being produced. The energy might not pour out steadily at all. It might be released in bursts like geysers, or escape through gaps in the surrounding gas. In other words, the most powerful escape in the known universe, from the one object that's supposed to allow none, is behaving in a way our best physics did not predict. We caught it. We measured it. And it still doesn't fully make sense. But step back and notice what every single one of these escapes has in common. The jet, the superluminal knots, the spin-powered beam, the galaxy-killing wind, the bullet streams XRISM just found. Every one of them is launched from around the black hole, from the disk, the magnetic fields, the spinning skin of space just outside the horizon. Not one of them came from inside. The event horizon has never, not once, let anything we can see climb back out. And there is only one thing physics says ever could. In 1974, Stephen Hawking predicted that black holes are not perfectly black. That at the very edge of the horizon, the laws of the quantum world force them to glow, to leak the faintest possible whisper of radiation, and over almost unimaginable spans of time, to evaporate completely. Hawking radiation would be the only true escape, not matter thrown from the neighborhood, but the black hole itself slowly turning into light and disappearing. It is some of the most celebrated physics of the last century, and we have never detected it. For a black hole like M87 star, that glow is colder than empty space itself, fainter than the afterglow of the Big Bang. And it would take something like 10 to the 67 years to evaporate, a number so large the universe has barely begun. So this is where the escape finally stops. Everything we have ever watched leave the black hole, left from outside the door. The one thing that could come through the door itself we have never seen, and may not see for longer than the universe has existed. So, what is escaping a black hole? Not what the headlines imply. Nothing crawls back out of the dark, but the rim of that darkness is the most violent engine in existence, spinning, bleeding, firing beams longer than galaxies, deciding which galaxies live and which go dark, in ways we are still, in 2025, struggling to explain. The black hole keeps its inside to itself. It just rearranges everything around it on a scale that should frighten you. We photographed the door 6 years ago. We still have no idea what it's like on the other side. If the edge of a black hole unsettles you, wait until you see what's at the center of our own galaxy, and the 12-year hunt to photograph the monster we're all quietly orbiting. That's next. Subscribe and don't look away.